Hi, and welcome to Jerry's Engineering Corner, and welcome to the second edition of Porex Vertex demonstration of its highly reflective material. My name is Jerry DiBattista, and I am the Global VP of Porex's PTFE Business Group. Today we are going to do two quick demonstrations on the highly Lambertian reflection of Porex's Vertex PTFE. Due to the COVID-19 pandemic, we are once again coming from my basement workshop. For the two experiments we're going to run, the first one we're going to show how a flashlight with a very specific pattern reflects off different surfaces. One is a mirror, which is a specular diffusion. The second is aluminum, which is between specular and diffuse. And the third is Porex Vertex, which is 100% diffuse. In the second experiment, we're taking a UV flashlight and we're going to change the angle that it's hitting the reflector, and we're going to measure the light that's coming off at one specific point. So for the first experiment, we're going to take a flashlight with a square light pattern, and we're going to reflect it off first the mirrored surface. As you can see, the image remains basically the same. As we move it over to the aluminum, you can barely see the square still in the middle, but you can see a very clear hot and cold zone within the reflection. And you move it over to the Porex Vertex and you can see the image completely disappears and very even light distribution throughout the whole surface. So for our second experiment, we're going to take a UV flashlight and a UV meter and measure the amount of UV energy being reflected off the sample at different angles. So we're going to start with the flashlight pointing straight down. As you can see, around 40 is the reading. As we go towards the sample, you can see the reading goes all the way up to the mid 600s. And you go away from the sample, the reading drops to virtually zero. So we go back to the middle, and we're reading around 40 to 50. Flip it over to the Porex Vertex side. Same location, you can see the energy coming off much higher, 262. Go towards the sample, about 450 to 500, and go away from the sample, still getting a reasonable amount of energy, even though it's pointing away from the sample of about 120. So once again, you can see how much more uniform the Porex Vertex PTFE is versus standard aluminum. So I ask the question again. If you're building a piece of UV equipment and need very uniform UV light distribution, do you choose a material like aluminum, which is partially specular, partially diffuse? Or do you pick Porex Vertex PTFE, which is 100% diffuse? Well, thank you for watching Jerry's Engineering Corner. That's it for me, Jerry with a G.